Alright, in this video we are going to be looking at combinations. And so let's go ahead and get started. Hold on just a second. Alright, so it says here there are 5 finalists to win 2 prizes, a brand new Ford F-150 for first prize, and a trip to South Padre Island for second prize. And how many ways can 2 winners be chosen? List all possible outcomes. So the first question we have to ask here is, does order matter? Well, of course it does. I'd rather win the Ford F-150 than take a trip to South Padre Island. So order matters. The prizes are different. And so we have finalists. And there's 5. We're just going to call them finalist A, B, C, D, and E just to keep it simple. So in how many ways can the 2 winners be chosen? List all possible outcomes. Well, first of all, this is a permutation, or actually it is a permutation, but we can use the counting principle, fundamental counting principle, to figure out how many ways there are to choose these 2 winners. So for first prize, we have 5 people to choose from, and for second prize, we have 4 to choose from, and so there's 20 ways to choose 2 winners from these 5 people, 2 different winners. Now the other way we could have found this is the number of permutations of 5 items taken 2 at a time, and that also gives you 20. So either way, you can use this permutation, or you can use the fundamental counting principle to see that there's 20 ways to choose these finalists for 2 prizes. Okay, so now let's write out the different possibilities. So it could be A and B, or it could be A and C, or A and D, or A and E. Notice it can't be A and A because it needs to be 2 different people. All right, well, let's see if B wins. It could be B and A if B wins first prize. B and A, B and C, B and D, B and E. That would be the 4 possibilities if B wins first prize. And then if C wins first prize, it could be C and A, C and B, not C and C, C and D, and C and E. And we can do the same thing for D, and for E. And so you can see there's 4 columns, or 5 columns of 4 in each, so that is 20 total outcomes. These are our outcomes. All right, now if we go down to the next problem, it says from the group of 20 finalists, and actually, you know what, I'm sorry, I want to write something down here. When we did 5 choose 2, or 5 permutate, or the number of permutations of 5 items taken 2 at a time, there's a formula. It's n factorial over n minus r factorial. In this case, n is 5, and it'd be 5 minus 2 factorial in the denominator. We end up with 5 factorial over 3 factorial, and eventually we do get 20. I want to show you this because of what we're going to do down here. All right, so let's look at number 2. From the group of 5 finalists, 2 will be randomly selected for a survey. And how many ways can this be done? So now notice they're just being chosen to take a survey. It doesn't matter what the order is, they're both getting the same survey. And so this is so here we're looking at how many pairs can we choose from these 5 people to be chosen for this survey. So I'm just going to go ahead and do this. It could be A with B. It could be A with C. It could be A with D or A with E. So it's really the same as what we had up here. However, here we can't do BA because that's the same 2 people we have here. But we could do B with C. We could do B with D and B with E. When we get to C, we already have C with A and C with B, so it'll have to be C with D and C with E. And then finally, well, actually we're not quite done. Actually, we are just about done here. If we start with D, we already have D with A and B and C, and so only thing we could put here is D with E. And so those are actually all the different outcomes to pick 2 people to take this survey. Again, order doesn't matter here. With the permutations, order mattered. With combinations, which is what we're leading to, order is not important. There's 10 outcomes. Here we had 20 outcomes. Okay. Well, let's go down to our definition and we'll come back to this. A combination is a group of objects selected without regard to order. The number of commutations of n items chosen r at a time is, well, we read this, n choose r, or n choose r, or this is the number of combinations of n items chosen r at a time. It's n factorial over n minus r factorial times r factorial. If you go back to our formula for permutations, it looks quite similar, except for we don't have the r factorial here. So we'll talk about that in just a minute. So on the problem we just did, we have 5 people to choose from, and we're choosing 2. Again, this is red, 5, choose 2. And that's equal, actually I should move this down just a bit. It's 5 factorial over 5 minus 2 factorial times r factorial, which here is 2. And this is 5 factorial over 3 factorial times 2 factorial. Basically, you could go from 5 to 4 to 3 factorial and stop. And it'd be over 3 factorial. And I'm just going to write 2 times 1 for 2 factorial. Notice the 3 factorials cancel. You're left with 20 over 2, which is 10. So again, this looks a lot like what we did up here, except for the 2 factorial here. Basically, what's going on here is we got to divide out the permutations of these 2 people here. You have A and B, but B and A is the same. And so for each of these pairs, there's actually 2 permutations. So we're really dividing out those 2 permutations. All right, let's go ahead and do some of these. We'll do some by hand and then some with the calculator. So 7 choose 3. That's going to be, so case n is 7 and r is 3 here. And so it's n factorial over n minus r factorial times r factorial, which is 7 factorial over, well, n minus r, that would be 7 minus 3. That's 4 factorial times r factorial, which is 3 factorial. So we can do like we did before, 7 times 6 times 5 times I want to go to 4 factorial so I can cancel this one. And that's going to be over 4 factorial. And we'll write this as 3 times 2 times 1. And so basically the 4 factorials cancel. Let's see, this is 6, and we have a 6 here, so we could literally divide out those, and we're left with 7 times 5, or 35. So we get 35 there. So I would encourage you to try the next one, and I'll put up the answer. All right, let's see how you did. This is 12 factorial over n minus r, or 12 minus 8, that would be 4 factorial times r factorial, that would be 8 factorial. And now 8 factorial is the biggest down here, so let's do 12 times 11 times 10 times 9 times 8 factorial. And I'm just going to write 4 times 3 times 2 times 1 times 8 factorial. These guys cancel. So we're left with these factors. Now 4 times 3 is 12. I could cancel that 12 with this 12. And then 2 here, you could cancel maybe the 10. Divide by 2, you get 5. And so we're just going to be left with 11 times 5 times 9. And you should get 495. Now you should also be able to do this on a calculator. See if we can get a nice picture there. That's not too bad. So you put in the 12 first, and then you hit the probability button. And it's the second option. So you could arrow down and hit enter. I'm just going to go ahead and hit 2 for option 2. And then we'll put in the 8. And notice you do get the 495. All right. On letter C, I think, one of the things I didn't tell you here is 0 factorial is defined to be 1. And that's kind of important here because our n is 5 here, so 5 factorial over 5 minus 5, or n minus r, that would be 0 factorial times r, which is 5 factorial. Well, 0 factorial is 1, so we get 5 factorial over 5 factorial. Any number divided by itself is 1. And I would encourage you to do letter D on your calculator. I mean, you could do it by hand, but I think just doing it on your calculator will be fine. So let's see. First of all, I'm going to put in my fraction button, and then we'll do 6, probability button, option 2, and then 4, and then 11, probability button, option 2, and then the 4, and we get 1 over 22. So you could actually do these separately, and you'd get 15 over 330, or you could do it all in one like I did, and you get, either way, you get 1 over 22. All right, let's move on to the next page. So Myrna has 12 CDs that he really likes. I think that should be a she. Of these, she is taking 4 on a trip. How many ways can she choose the 4 DVDs? So she's just grabbing 4 out of her 12 DVDs. Order is not important here. She just wants to have 4 DVDs she can play on her trip. And so order is not important. That's what's always going to be true with combinations. And so we have 12 DVDs to choose from, and 4 are being chosen. And so this is 12 choose 4. And if you plug that into your calculator, you should get 495 ways. All right, you're certainly welcome to try the other problems, or at least see if you can figure out any of them, and then come back and check your answers. All right, let's look at number 5. So here, from a list of 15 books, students in a literature class must read 3 of the books and submit a book report. And how many ways can the books be chosen? So we're choosing 3 from 15, and it doesn't matter order. Order is not important here. We're just reading 3 of these books and doing book reports. And so it's 15, choose 3. And there's 455 ways. You can plug that into your calculator and you'll see. Let's go to number 6. To win $1 million in Texas playing Powerball, person must select the first 5 winning numbers where the numbers range from 1 to 69. The order in which the numbers are chosen is not important. In how many ways can the 5 numbers be chosen? Well, again, order doesn't matter here. We're just trying to pick the 5 numbers that come up when they do their drawing. So there's 69 numbers to choose from, and we're choosing 5. That's 11,238,513. So basically, if you buy 1 ticket, you've got a 1 in about 11 million chance of winning $1 million. All right, let's go on to number 7. How many 5-card poker hands are there given that there are 52 cards in a deck of cards? How many 5-card poker hands? Well, we're choosing 5 from 52, so this is 52, choose 5. And you should get 2,598,960 hands. So there's a lot of possibilities. Wow. Lots of possibilities. All right, let's move on to number 8. A committee of 4 instructors and 3 students is to be formed from a group of 7 instructors and 11 students. So notice 7 instructors, 11 students, that's a total of 18 people. Actually, we won't need that since we're not actually finding the probability here. So 4 instructors and 3 students from 7 instructors and 11 students. Actually, I'm going to erase this. I don't need that. Well, and how many ways can we choose the 4 instructors? Well, there's 7 to choose from, so that's 7 choose 4. We also need to find the number of ways to choose 3 students from 11. So that's 11 choose 3. So this is the number of ways to pick the instructors. This is the number of ways to pick the students. And if you multiply, that gives you the number of ways to do both. So I got 35 times 165, which is 5,775 ways. We're just using the fundamental counting principle there. So again, this is the number of ways to pick the instructors. This is the number of ways to pick the students. This is the number of ways to pick both. All right. Last question. What is the difference between a permutation and a combination? Well, basically, it's all about whether or not order matters. With permutations, order matters. With combinations, order is not important. All right, that's it for this video.